Hello everyone, welcome to workbook. The question says that the sum of the coefficients of the first three terms in the expansion of x minus 3 upon x square whole to the power m, where x is not equal to 0 and m belongs to the set of integers is 559. Find the term of expansion containing x cubed. Let's see how can we find that term. First of all, the given expression is x minus 3 upon x square whole to the power m, where x is not equal to 0 and m belongs to the set of integers. Now let's see the solution. And for the solution, we will take the help of binomial theorem. As per binomial theorem, the general term or the r plus 1th term for expansion of x plus a whole raised to the power n is given by NCR x to the power n minus r a to the power r. Now the expression which we have in the question is x minus 3 upon x square whole to the power m. This is of the form x minus a whole raised to the power n. We can solve this in this form also, but converting it to the form x plus a whole raised to the power n will make our task a bit more easier. So we will convert this like x plus minus 3 upon x square whole raised to the power m. Now this is of the form x plus a whole raised to the power n. So accordingly, tr plus 1 for its expansion will be equal to mcr x to the power m minus r into minus 3 upon x square whole to the power r. Let me simplify this tr plus 1 a bit more so that it will be easier for us to calculate the coefficients. So this is equal to mcr x to the power m minus r into minus 3 to the power r into, if I take x square to the numerator, then x will have a power which is minus 2. So I'll get x to the power minus 2 whole to the power r, which is equal to mcr x to the power m minus r. I can write plus minus of 2r into minus 3 to the power r, because for any x to the power a into x to the power b is equal to x to the power a plus b. So then I'll get mcr into minus 3 to the power r into x to the power m minus 3r. Now we will get the coefficients of the first three terms as given in the question. So the first term, which is t1, can be written as t0 plus 1, which will be equal to mc0 minus 3 to the power 0 into x to the power m minus 3 into 0, which is equal to mc0 is 1, minus 3 to the power 0 will be 1 into x to the power m, which is equal to simply x to the power m. And t2 will be equal to t1 plus 1, which is equal to mc1 minus 3 to the power 1 into x to the power m minus 3 into 1, which is equal to, the value of mc1 is m into minus 3 into x to the power m minus 3. So this is equal to minus 3m times x to the power m minus 3. Now t3 can be written as t2 plus 1, which will be equal to mc2 minus 3 to the power 2 into x to the power m minus 3 into 2, which is equal to 9 times mc2 is m into m minus 1 divided by 2 into x to the power m minus 6. So the three consecutive coefficients we got are, one is 1 here, second is minus 3m, and third is 9 by 2 whole multiplied by m into m minus 1. Now as per the question, the sum of these three coefficients is 559. So we have an equation which is 1 plus minus 3m plus 9 by 2 times m square minus m, if I multiply m into the bracket, is equal to 559, which indicates minus 3m plus 9 by 2 times m square minus m is equal to 558, which indicates minus 6m plus 9m square minus 9m is equal to 1116. Now I'll get an equation which is 9m square minus 15m minus 1116 is equal to 0. If I divide this equation by 3, I'll get 3m square minus 5m minus 372 is equal to 0. Now this is a quadratic in m, so let's factorize it so that we can find out the roots. So if we factorize, this will be 3m square minus 36m plus 31m minus 372 is equal to 0. If I take 3m common from these two terms, I'll get m minus 12 in the bracket plus, if I take 31 common from these two terms, I will get 31 times m minus 12 is equal to 0, which indicates 3m plus 31 into m minus 12 is equal to 0, which indicates either 3m plus 31 is equal to 0 or m minus 12 is equal to 0. So in turn we get m is equal to minus 31 upon 3 or m is equal to 12. But as per the question, m belongs to the set of integers, so we cannot accept minus 31 by 3 as one value of m. So value of m will be 12. Now the question has asked us to find out the term of expansion containing x cubed. Okay, so for that we will again write the expression for tr plus 1, which is equal to mcr minus 3 to the power r into x to the power m minus 3r. So for finding out x to the power m minus 3r to be x cube, so we need to make m minus 3r is equal to 3, which indicates if I put the value of m here, this will be 12 minus 3r is equal to 3, which indicates 3r is equal to 9 or r is equal to 3. So I will substitute the value of r in the expression of tr plus 1. So then I will get T4 is equal to 12 C3, because m is equal to 12 we have calculated earlier, into minus 3 to the power r, which is 3, into x to the power 12 minus 3 times 3. So this will be equal to 12c3 into minus 27 into x to the power 3. The value of 12c3 will be 12 into 11 into 10 divided by 3 into 2 into minus 27 into x cube. So if I calculate the coefficient, it will come out to be minus 5940, and we have x cube. So this, hence we have calculated our answer, which says T4 is the term containing x cube and T4 is equal to minus 5940 times x cubed. Hope you guys understood the explanation. Thank you.